Hello. We're working on discussion 10 from spring 2015, CS61A. And we've just sort of reviewed what iterators are and iterables. And we're asked here to define an iterator whose ith element is the result of combining the ith elements of two input iterables using some binary operator, also given as input. The resulting iterator should have a size equal to the size of the shorter of its two input iterators. Okay. All right. So let's take a look at the doc tests here. So we have some combiner, and we're given in two iterables, it says, right? And so our first call looks like it's going to do 0 plus 0, which is the call to next on naturals and the call to next on naturals again. And then 1 plus 1, and then 2 plus 2. Okay, so this sort of makes sense, right? We've got our combiner, and we've got sort of what looks to be a stream of natural numbers, right? So some sequence of calls to next to natural. Okay. Well, so first off, iterators keep track of their state, right? So if I am defining an iterator, normally I would want to keep track of some like self.current. But since I've passed in two iterators, or two iterables, then I know that I'm just going to use these to keep track of their own state. And since I'm just adding up what looks like I'm just adding up calls to next for each of these iterators. So, but we still need to keep track of this because we're going to define some next. And so let's do that with instance variables. So we'll say self.iter1 is equal to, so this is, we've been told that this is an iterable. And so let's call iter on iter1 just to be safe. So we know that we're going to get an iterator out on self.iter1. So self.iter1 is going to be the iterator of whatever iter1 we passed in. And that's different than an iterable. An iterable only needs to enforce, only needs to have the method iter. An iterator we know is going to have the method next. Okay, so let's say iter2 is equal to iter2, lots of iters here. And then we need to keep track of our combiner in calls to next. Combiner, and we're going to say combiner. Okay. All right, so we've kept track of our state here. We know what our two iterables are, our two iterators are, and we're able to access them from all of our methods. So now since we're defining an iterator, we need to implement next. Whoops. And next takes no arguments. Okay. And so let's sort of pattern match and see what we return here. It looks like we're going to add up. So use our combiner and apply it to two calls to next on our iter1 and our iter2, right? So let's return next. Well, let's do self.combiner. In this case, it's going to be add, right? On a call to next for iter1 self.iter1 and a call to next on self.iter2. Okay? And so remember let's do a sanity check on next. What does next need to return? Well, it needs to first think about, am I done with my iteration? And if I'm done with my iteration, then I want to raise a stop iteration exception. So specifically, we want to make sure that the iterator has a size that's equal to the size of the shorter of its two input iterators. And one thing that we know about each of these iterators is that when they're finished once they're finished going through their calls to next, and they've reached a stop iteration exception, they're going to actually raise a stop iteration exception. And so as we continue to go through and make calls to our IteratorCombiner, what we're going to get is we're going to call next on self.iter1, and if this is the shorter of the two iterators and it's finished iterating, then it's going to raise a stop iteration exception, which if we don't catch it here, is going to raise a stop iteration exception on our call to next, and we will have stopped our iteration and signal to next that we're no longer iterating. So that's why we don't need to explicitly raise a stop iteration exception right here, because one of our calls to next on our shorter of the two iterators is going to actually raise that exception for us. Okay, so technically we're done, right? Because we were just asked to define an iterator. But if we want to be complete and add add the iterable interface in here as well, we can define the iter method, which we're going to say is just going to return self. And the reason we can just return self is because we've defined a next method for this class IteratorCombiner. Okay, so let's continue with this problem. It sort of builds off of our definition of IteratorCombiner from the previous problem. We will define a single instance iterable of naturals, which if you look on your discussion handout is a iterable that is going to create the sequence of natural numbers 0, 1, 2, 3, 4, etc. And we're going to also create a instance of our IteratorCombiner class from the previous problem that is going to take as its iter1 naturals, and as its iter2 the same instance of naturals with a combiner that's add. So let's think about what next double naturals is going to do by looking up at our code from the previous problem. So we will have set self.iter1 to be the first instance of naturals, and self.iter2 is going to be the same instance of naturals that we have ascribed to self.iter1. So when I call next, what I'm going to do is I'm going to call next on self.iter1, which in this case is naturals, and next again on self.iter1 on self.iter2, which is also naturals. So let's think about what that's going to give us. So I'm going to return adding. I'm going to add a call to next on naturals and a call to next on naturals again. And now we sort of think about how we evaluate our arguments and operate as an argument. So we evaluate this function call by looking and see what add is. We know what add is. What's the first call to next naturals? Next naturals, what's going to be a 0. And the second call, since naturals has incremented its current counter, has changed its state after this first call to naturals, this is actually going to be a 1. So we were going to add 0 and 1, and we're going to get a 1 out. And the reason that we put this problem in here is it's a little counterintuitive, right? It looks like from our previous example, from the previous doc test that we gave you up here, that this should sort of behave in the same way, right? So we have a natural iterator, or natural iterable right here, another naturals iterable, and we get 0, and then we get 2, and then we get 4. This is a little bit different, right? Because our naturals is actually going to keep its state. So when we make our first call to naturals, we'll change our current counter to be 1, and then our next call is going to get that 1 out. So this is going to be 1 instead of 0 as it was in our last example. So now when we call double naturals again, we're going to sort of think about this same call, and we're going to end up adding our first call to next naturals is going to give us a 2, and our next call to next naturals is going to give us a 3, and so we're going to get 5 out. Okay, so back to this. Alright, so if you have any questions about this, please feel free to leave a comment on a Piazza or on YouTube, and we'll get them answered as soon as we can. Great, thanks for watching.